Okay, this is question number 5 on the additional maths paper from WJC from 2019. So the first thing I noticed with this question is that you are going to be assessed on your written communication. So we have to make sure all our units are perfect all the way through. We have to make sure that our working is clear and concise. So let's have a look at what we got. We got the 3D shape below is such that trapezium A, B, C, G. So A, B, C, G. So this is a trapezium. So these two sides are parallel, but these two sides are not. But that is congruent to trapezium F, H, D, E. So congruent means it's exactly the same. Okay, so any length on the front, so this one's 2.5, the back one's 2.5. If this one's 6.2, the back one's 6.2, 8.4, 8.4, and so on and so on. So that means this length here will also match up with that length there. All the other faces are rectangles, so that's an important point. So if all the other faces are rectangles, what we have are a lot of right angles in there. Okay, so there's a right angle there. This is a right angle right there. All of these are right angles because that's a rectangle on the bottom. This is a rectangle. So we've got right angles everywhere for us to try and have a look at. We want to calculate angle, so that little hat means angle, ECB. So let's draw that to start with. So E to C to B. So we're looking at this angle in here. And it kind of makes sense to me to join E and B to come up with a triangle. Now, the important thing here is to note that this is not a right angle triangle. So even though we got all the right angles, this one is not a right angle because this length here, BC, isn't a vertical side. It's leaning slightly. You can see it there. It's the same as this HD. This is vertical, so it's leaning slightly. So if we want to try and work out an angle in a triangle, and it's not a right angle triangle, you're probably going to be looking at advanced trigonometry. So your sine rule, your cosine rule. Now, if I'm going to use the cosine rule to find this angle, I'm going to need to know all three sides of this triangle. So let's see what I can do that's nice and easy. So the first easy one, I think, for me, is going to be this length here, EC. Because EC is in the triangle ECD. Okay, so if I quickly sketch ECD, okay, it doesn't have to be particularly big, so that's E, there's my D, there's C, this is 6.2 centimeters, and this is 3.7 centimeters, and this length here, EC, that's this red one that I'm trying to work out. Okay, so I can use Pythagoras because this is a right angle triangle. So I can say, using Pythagoras, that 3CD squared plus ED squared will equal the hypotenuse, which is CE squared. I'm going to change that ED to DE just so it's all in alphabetical order. So if I look at what we've got, CD is 3.7. So that's 3.7 squared. Plus DE is this length here, 6.2. So plus 6.2 squared equals CE squared. So what I'm going to do is to work out that left-hand side. So I've got 3.7 squared plus 6.2 squared equals 52.13 is CE squared. And then if I square root both sides, that implies that CE is going to be, so the square root of the 52.13 is 7.22 to 2 decimal places. So that's centimeters. So I now know, I found out that this is 7.22 centimeters. So now I'm on my way. I need to find out the other two sides now. So let's see what we can do. If I create a perpendicular from D, so if I go up here, so I make that a right angle, then I can work out this little bit by here. Because I know that it's 8.4 centimetres all the way, but it's only 6.2 up to this point. So this little gap here, that little gap by there, is 8.4 minus the 6.2. So 8.4 minus 6.2 is 2.2. So I know that's 2.2. I also know that the height of it, so we've got this right angle triangle here now, the height of it is 2.5. So let's give that a name by here. Let's call this, have we got E, F, G, H? We haven't got an I yet, so I'm going to call that point there I. So let's draw a triangle HID. Okay, so I've got my I, my H, and my D. There's a right angle. I've just worked out that this is 2.2 centimetres, and my ID is the same as my EF, which is 2.5. Okay, not particularly to scale, but it does say in the question that the diagram is not drawn to scale. So I can use Pythagoras again to say that HI all squared, so the smaller side there, plus DI all squared will equal this length that I'm looking for, and that length is another one of my red lengths here, is HD. Okay, it's this length here at the front, but you can see that that matches with the BC at the back because of the congruence. So that is HD or DH all squared. So if I put in my information, this is 2.2 squared plus 2.5 squared equals DH squared. So if I work out 2.2 squared plus 2.5 squared equals 11.09. So 11.09 is DH all squared, which if I square root everything, tells me that DH is 3.33. So that's two of my three sides worked out. It's this one has been done, and now this one has been done. Was I 3.33? Now I need to look at this side. Now this side is a bit of a pain because this isn't a right angle triangle, so we can't use that. So we have to try and use a right angle triangle to try and help us find it. So the right angle triangle I'm going to use is going to be this one. FEB. So there's a right angle there. Now I know the 2.5. I don't know this one. That's what I'm trying to work out. And I don't know this one actually. So there's not a lot I can do with this triangle yet until I can work out one of the other sides. Now it's not going to be this one, because that's going to be my overall thing that I'm trying to find. So I'm going to have to try and figure out what this side is. So I can do that by using another right angle triangle. I can use that by using AFB. So because this is a right angle, by there, I know that this is 8.4, and I know that this length here, AF, is going to match with these lengths here, which is 3.7. So if I draw my triangle AFB, try again. It doesn't like me this time. There we go. Right, so we got A there, F there, B there. So I know that AF is 3.7. I know that AB is 8.4. So I can work out this FB, so this distance across the middle here, using Pythagoras. So I can say that AB all squared plus AF all squared is going to equal this BF all squared. So I put brackets around them. I don't need brackets yet until I substitute. Okay, so my AB is 8.4. So this is 8.4 squared plus AF is 3.7 squared. This is my BF all squared. So 8.4 squared plus 3.7 squared is 84.25. Is my BF all squared, and that implies if I square root both sides that BF is going to be... Oh, that's not going to help me. Don't know what I'm talking about. Let's try again. Okay, now I know that that's 9.18. Now I know that this BF across the top is 9.18. I can use another triangle to try and help me out. This is a right angle. I got 2.5, 9.18. And then that's the side I'm looking for. So I'm looking at triangle EFB. Let's try and draw it. There we go. So we got E at the bottom, F, B. So we've just worked out that, or we can just see that EF is 2.5. FB or BF, we just worked out is 9.18. So this side that I'm looking for, this is my last of the red sides, can be worked out using Pythagoras because this is a right angle by here. So I get BF all squared plus EF all squared equals BE all squared. So that's 9.18 squared plus 2.5 squared equals BE squared. So that's, well, BF all squared, well, we've actually got an expression for that there. It's 84.25 plus 2.5 squared. So we've got 84.25 plus 2.5 squared is 90.5. And then if I square root both sides, I get BE is going to be root of that, which is 9.51. Okay, so I now have 0.5 degrees. Very long, but this is what you should be getting. So the angle that I want to work out is this one in here. So this is this B or ECB that they're talking about. ECB, there it is. So I can use the cosine rule. If I'm going to use the cosine rule, this is going to be this angle I'm going to label A. So this side over here will be little a. I've already got the side here labeled B, so I may as well incorporate that and call this one little b. Third one will be C and little c. So if I write down my cosine rule, which is cos A equals B squared plus minus my so I may as well use the notation that we've been given for the angle, so cos of ECB equals, okay, so now my B squared is 7.22 squared. Now my 7.22 squared, my 7.22 is coming from here, so it's going to be 52.13. So I don't need to square that because that's 7.22 squared. Plus the c. So my little c is this 3.33, which came from the square root of 11.09. So if I square 3.33, I get 11.09. Minus a squared, which is this 9.51, which is this one here, the square root of 90.5. So it's minus 90.5 all over 2 times b, well b is this 7.22, times c, which is 3.33. Now, if I'm going to be as accurate as possible here, then the 7.22 I am going to get from doing the square root of 52.13. So I could write root 52.13 in there. And the square root and the 3.33 came from the square root of 11.09. So I could write the square root of 11.09 in there. That will give me everything as accurate as possible. So because there's opportunities to round in here, you might have a final answer that's slightly different to my one. That's fine, as long as it's pretty close to... Okay, so I'm going to make my substitutions now. So when I type all this in on the right hand side, I end up with negative 0.567 and so on and so on coming through. And if I want angle ECB, then I need to inverse cos both sides. Again, I'm not going to use the rounded value. I'm going to be as accurate as I can be. So that's inverse cos of the answer, 124.6 degrees. As I said, there will be some leeway if you did use an approximate value, but hopefully your answer is going to be pretty close to this one.